and post regularly in all those places. So tonight's speaker, Mark Michaelis, CEO and founder of Intellitech, longtime Microsoft Regional Director and MVP, longtime author, Essential C#, so has been with .NET and C# since the very beginnings, before the beginnings, probably, and even wrote books on C++. So one could argue that was, part of the beginnings of C#, I don't know. So anyway, Mark does, obviously does a great job presenting, lots of great material. Anything else you want me to say about you before? No? Nothing else?
Got one. There you go, Chief Nerd.
Chief Nerd, as well as Chief Nerd. We've got a lot of titles for Mark, but we'll leave it at CEO.
Some of them are not as keen as others.
All right, cheers.
Thank
Have
you.
at it.
How about now? Good deal. We have a mic. I hear PowerPoint is really important, but today we're going to skip it. Okay, Phil's already done the introduction. There's my contact information if you want to see that. And we're going to talk about guidelines. So before we get started, give me some idea of which version of C# you guys are using today actively. So let's start with higher than 8. Who's using higher than 8? Maybe I should change the question. If you're using 8 or lower, raise your hand. We got several people using 8 or lower. Okay, how about 9? C# 9 or lower. And I guess I should say just 9. 9. C# 9. Anyone using C# 9? No? C# 10. Okay, we got a few C# 10 users. Okay, anyone on the bleeding edge with C# 11? No, nobody's yet exploring that. So I'm going to talk mostly, the focus, there's not a lot of in 11 that we're going to talk about. So I'm going to focus mostly on 9 and 10 and just sort of the changes that those languages have introduced for C# coding guidelines. So that's the focus. There's 4 ways we sort of categorize the guidelines. The first one is there's do guidelines. And if you want to sort of think through, these are, if you're a climber, a rock climber, you do wear a helmet, and there's pretty much no exceptions. Like there should be no case you're not wearing a helmet. You could be climbing indoors, you should be climbing outdoors, but you should wear a helmet. If you're into sort of security, firewall security, you do want to have a firewall. There's not really any cases where going without a firewall is a good idea. So pretty much all cases. And essentially what we say with do guidelines is you should always follow them. We're only exceptionally unusual corner cases. There are only exceptionally unusual corner cases that would sort of warrant a violation of a do guideline. It's really a do this all the time. There's no cases. So you could argue, well, if I'm only climbing, 3 foot or less, then maybe I could do with a helmet. But what kind of climbing is that anyway? So it doesn't really matter. And those may be just exceptional cases, but really we say we do always. And in the C# case, we want to say do name custom attribute classes with the suffix of attribute. There's no real case, unless you want to sort of show a case of what not to do, that you would not suffix an attribute name with attribute. And so we say, hey, you do this always. The next category that we have for guidelines is consider. These guidelines you should be generally followed unless you fully understand the reasoning of why your case is special. So for example, you should consider using 3 anchors when securing a top rope. Like that makes sense, especially if you're doing it yourself. But there's sort of cases where you're hanging on the edge of a cliff, there's not a chance to do that. Not that I would have ever done this, but there are some cases we sort of drop that down to 2. Or, the anchor's already set inside the rock and you're going to go ahead and use that and you're not setting your own stuff. That might be an example. Or we may consider turning off firewalls on workstations within the local network. That, there's a reasonable case that there's exceptions. You should know what you're doing. Don't do this willy-nilly. There are cases where your partner, coworker got a virus and you ended up with a virus because you weren't running a firewall. You should know the consequences of your choices. In the C# space, we should provide special enums values for commonly used combinations of flags. So here's an example. It would make sense that you would have a flag for none. right? Even though this doesn't exist, but it's reasonable that we should go ahead and provide special enums for combinations or things like none. That's a pretty good case. Do we always do this? No. Should we consider doing this in all cases? Yeah. If you've got a flag enum, you should always at least consider this. Like that's something you should always consider. So we've got the case of consider. Next comes the sort of void. This is in the similar sort of severity as consider. You should avoid doing this, but you might have some corner cases or good reasons not to do this. For example, avoid putting the rope in the dirt. Like that's a good thing, but if you're climbing a mountain, you've got dirt right there, and you don't actually have a rope bag, you may sort of make some exceptions, and the rope will end up in the dirt. Or if you're canyoneering and you're going down some 300-foot cliff, and you may find there's just nothing else, and you haven't carried a rope bag because you're carrying the rope in your back. There's cases where the rope gets in the dirt, but generally you want to avoid that. You want to avoid clicking links with sources that are unverifiable. Surely this is really important, but we have all done this, right? We've all sort of checked the email and looked, oh, that one looks pretty good. I'm going to click on it, and we'll see what happens. Most of us, we don't actually know where it goes. We look at the URL at best, but every now and then, maybe more often than not, we click anyway, even though we should avoid doing that. We should, again, know what the risks are. You're doing it on a VM, you don't care. It's an okay example. Or you're in the C# where we say avoid marker interfaces with no members. Like this, you should just avoid doing that. You might have some rare case, for example, if you're writing a book and you want to say don't do this, and you want to show what exactly it is you shouldn't do, that might be a case where you want to sort of not do that. But generally, we avoid sort of marker interfaces. And then lastly, sort of, again, a much more serious of the consequence of do always. You do not ever do not enter a slot canyon when there's risk of a flood. This is a bad thing to do. Like there's pretty serious consequences to drowning. It does put a sort of a damper on the rest of your life. So probably something you want to avoid if at all possible. Don't download files from untrusted sources. That seems like a reasonable thing. You just don't do. There's not really any cases that you want to avoid this. And in the case of C#, do not give class names a prefix of C. Right? That seems fairly logical. We prefix interfaces with I, but let's not go prefix class names with C. That's a pretty much like just do not do that. Like there's no exceptions that you would want to go do that. So the question asked, is there any other category of sort of guideline? And were we missing anything with those four? And I would argue that no. It's pretty much if you've got a guideline, it's going to fit in one of those four, and you should reword it so that it does. That's a pretty comprehensive list. It's only 4, but it should cover all the cases of, hey, we're talking about guidelines here. We've given you some wriggle room if you're going to use consider or avoid, and we've given you no wriggle room in the do not and the do cases. And that should cover us for all scenarios. And that's a pretty good way to sort of say, let's follow these guidelines. The guidelines exist, should be according to that. Thoughts? We good? Okay. So let's start with the easy one. I do use file scope namespace declarations, but I should preface this. There's an important case scenario. I am not going to prefix guidelines and say, if you happen to be in a version of the language that does not support file-based guidelines, then don't use them. I'm going to assume that in all cases, if the feature is available, then the guideline applies. So if you don't have file-based namespaces, then clearly this is not a good guideline to follow. If you're programming in C# 8, for example, or C# 9, you probably want to avoid this. But hey, if you've got the ability in C# 10 to do file-based namespace scopes, you should just always do this. And if you think about it, I love the fact that when I had to use standard sort of scope namespaces, I got to indent by 4 characters, taking away my 100. I lost 4 every time, and it really provided no value whatsoever. And when the language was designed, this was really clean. We put these curly braces in, and we indented everything inside, and that was beautiful. We all thought that was wonderful. But after you've coded maybe 5 or 6 files, you're like, why am I losing all this space on the left-hand side? That's kind of ridiculous. But it only took us 10 versions of the language to figure this out. So, it was a little bit difficult to notice that this wasn't as beautiful as we thought it was. So really, there's no cases where you don't want to go with file-based namespace declarations if you have them available. I should point out that you can't mix them. So if that's not a possibility, you can't go ahead and use file-based namespaces and then do sort of regular scoped namespaces. That's not a possibility. But if you're putting two namespaces within a file, that is already breaking a guideline anyway. So we have a guideline since C# 1.0, which is one class per file. So why on earth are you having two namespaces within the same file? That seems a little bit ridiculous. And so in order for us to want to do this, we'd be breaking other guidelines anyway. So yeah, the language doesn't support it, but you shouldn't be doing it anyway. So. How are we doing? Good. We got agreement on this one. So that's good. I was kind of wondering where that one's going to end up. So let's take another one, a little bit more controversial here. So here we're going to look at sort of standards in C# 1.0, some sort of struct guidelines. If you're going to define a value type, these are some pretty standard things you want to go ahead and do. For example, do not provide a parameterless constructor for a struct. Okay. That's very important. You don't want to go ahead and provide it because it won't necessarily run, just to clarify what's going on. And do not define mutable value types. So you shouldn't be writing value types that can be changed over time. The compiler is actually much smarter at this. That mostly prevents you from doing this. But a while ago, it used to be sort of if you pass something and then you did a dot operation, you could change the value type. But when the stack unwound, the value type would go back to its original value. It was very confusing. And it's very hard to debug if you had it. The compiler is actually quite smart in preventing this today. So it doesn't happen that often. But in general, we don't want to go ahead and define mutable value types. That sort of goes against the concept of sort of a value type working. Another one, we do want to ensure that state where all instant data is set to 0, false, or null. So by default, if you're going to go ahead and create a value type, since it's not always initialized, when is a value type not initialized, for example? When would a value type not be initialized? Let's imagine you have a non-default constructor on your value type. When would it not be initialized? No, it's not an optional case. It's actually much simpler than that. Yeah. Any clues? Not a trick question. What's that? Yeah, I'm not sure what you can do with something before it's created, but go ahead, Tyler. Yeah, by definition, but give me some code where this would happen. It turns out that the scenario is really common. It happens all the time, actually. Go ahead.
Like you did like a null check on something, and you had to escape.
Yeah, but it's not. You can't have an instance of it. When the question is, when do you have an instance that's not initialized? I have an instance of the type that's struct and it's not initialized. A nullable value type. That's pretty impressive that you did that. Nice job. A nullable value type. So if you have a nullable value type, it is by it is not initialized, but it's still null. So there's actually not an instance. If it's null, it's not an instance. So a nullable value type, while it is true that the variable is not initialized, it's not true that the data within the instance is not initialized because there is no instance. It's actually much more simpler than this. If you go ahead and declare a class that has a value type on it, and it's a not nullable value type, when you instantiate the class, the value type isn't initialized. So this happens all the time. Presumably you've got cases where you declare a person and the person has a property or a field of age, and if you don't initialize it, it's going to be default to 0. And any value type that you declare on a reference type, it's not going to get initialized. In fact, any value type you declare on a value type has the same problem. So there's many scenarios where initialization doesn't occur, even if you have a non-default constructor. So the point about this standard here, this guideline here, is essentially saying, hey, if it's not going to get initialized, make sure that the 0 values of this instant are valid. And so the guideline here is, hey, set it to such a way. So for example, you wouldn't say, you wouldn't have something like is not set, or is set when it's going to default to 0 if that was the valid value that you wanted to have this value type. And then another one is sort of more complex, but and there's a bunch more like this, but do implement I-equitable. And if you implement I-equitable, what is that? What also are the implications of doing that? I did an abbreviation of this, but essentially you have to implement the concept of equality on a value type. And that has a whole bunch of implications. For example, you actually need to go ahead and implement a get hash code. How many of you, off the top of your head, know what a good implementation of get hash code is? Just, this is a good, okay. Turns out it's got a lot easier, especially if you use tuples. But, this is not a common algorithm that most of us knew until tuples came out, and then tuples sort of solves this for us in some easy ways. But you have to go ahead and implement get hash code. You also have to go implement not equals. You also have to go implement equals, the equality. You have to implement I-equitable. So it's the burden of trying to get this done correctly is fairly burdensome. It's a hassle. And there's a lot of stuff you have to do. And that's the main reason why I would sort of go ahead and argue, if you're going to go ahead and use records, we've got a bunch of guidelines. I mean, if you're going to go ahead and declare a value type, my suggestion is you do declare a value type as a record. Okay, you do declare a value type. Let's just sort of review the value type case. So here I've gone ahead and declared a record struct. I've gone ahead and declared a coordinate. It's a value type. And the data type has longitude and latitude. It's also got a constructor on it, which, by the way, is added as a new feature in case you want to, where you can actually put a default constructor sorry, let me rephrase that. If you have a struct, not a record struct, starting in C#10, you could actually go ahead and declare a default constructor for a struct. But it turns out that is no longer relevant because you no longer declare structs because you're going to use records. So going forward, essentially in all cases, you will declare a struct as a record struct. And the main reason for doing that is you get the implementation of equitable or I-equitable for free. You get all of that stuff without having to go implement it by hand. And for that reason, you're essentially always going to go ahead and do that. In full disclosure, there is a weird case where this might not happen. We happen to have a type inside C#. I think it came, I want to guess C#6 or so. We had this type introduced called a tuple. It's actually not a tuple. It's actually a value tuple. And the value tuple breaks all the rules that were established in C# 1.0 for how you should go ahead and declare value types. For example, a value tuple doesn't have properties, it has fields. Now, there is no other type in the framework that we expose a field publicly. Like, that's insane. You should always wrap it with a property, right? Standard guidelines. You shouldn't do this. And it turns out that tuple breaks that rule. We should go ahead and make sure tuples are not mutable. Well, it turns out tuples break that rule. So there's a bunch of stuff where there's just a corner case. It's really rare. But if you're defining one, I haven't come up with any, even imaginable one. I can go to fruits and animals and imaginary things, and I still can't come up with a reason with why you would not use records. So we're just going to assume that tuples are a really weird case. We'll basically say it only is there because the language didn't have tuple in the very first version. If it was in the very first version, we wouldn't have this problem. Anyway, so in all cases, if you're going to define a value type, you should use a record struct, and that seems like a pretty good rule. Okay, let's keep going back to our rules about structs. And I'm going to switch over to preview mode here. You have the option with records starting in C#10. You can go ahead and declare value types of structs and reference types of structs, so both are available. In the first version, if you declare a record without specifying, well, if you declared a record, then it was, by default, it was always a reference type. Okay, so C#9, when you declared a record, it was a reference type, and you didn't specify struct or class. In C#10, you get to specify struct or class, And my proposal here, or my guideline, not proposal, it's a guideline. The guideline here is you should always specify explicitly whether it is a struct, meaning type the word struct, or a class. So if you go back to the example we had here, you'll notice here I said record struct, and if you wanted to change it to a class, it would be record class. But you should always specify which what type it is, even though it is optional, in which case it defaults to a reference type. Oh, this is an important one. So here you'll notice I've got the declaration here of person. It takes in a name. So we have a parameter, and we essentially have a case where we all know this. Like we've been coding this in C# 1.0. You should always name your parameters with camel case. Always. Well, except if you're declaring a record that has a positional parameter. That's the one and only case you shouldn't do this. And so I'm being very clear here. Here, you'll notice I have a parameter. It is name, and it is Pascal case. And I'm breaking the rule that's been around for all time. Well, all C# time. Parameters should always be Pascal case. Why am I breaking the rule? Yeah, so a positional parameter on a record, declares a property. And the name of that property is a public part of the interface in way less of a way than the parameter name is. You know, that it is a little bit part of a public interface, but not quite as much. So because this is going to become a public part of your interface, and the C# guideline is you should always name public members with Pascal case, we are therefore going to take a positional parameter on the declaration of our record. We're going to go ahead and make that Pascal case, not camel case. That's a guideline. Just do it always. To the point that you can imagine the C# team sitting around and going, should we allow them to put a lowercase Pascal case and automatically change it? Like, what are we going to do here? This is really inconsistency. We just follow the guideline. Positional parameters should always be Pascal case. How are we doing? We good? Let's go. Okay. Do use record structs when defining value types. I've already said that is a rule. We want to always make sure we do that. It turns out that on record structs and record structs only, you can add a modifier to the declaration of the type of read only. And that automatically makes it immutable. Now, I'd like to say here do, because we already have a rule that I mentioned earlier. When you're going to go ahead and define a struct, it should be immutable. It should not be changeable. And for that reason, but we have this little corner case of a tuple out there that doesn't follow the guideline. And it's actually a really well-designed class. Like, I mean, in spite of the fact that it breaks all the rules, it's a really well-designed class. Like, really, really well-designed. In fact, it's designed so well that there was actually a system.tuple earlier in the framework, in the language before, so the V5, and they had to write a new one called value type that was so much better because it really was designed well. So here, what I'm saying is, assuming that you do not define mutable value types, then this rule would be do not. But really, it's considered read only as a modifier on your struct, so that it doesn't get changed and cannot be done. The advantage of the read-only declaration here is that you cannot go ahead and modify any data within the struct after it's instantiated. And so that's a really important characteristic. So you can't make a mistake. Oh, well, you know, in this case, I did a rotate method on my struct, and I happened to change the coordinates to be able to rotate the other direction. Well, that might be really useful, but it turns out it's very, very dangerous because you're actually modifying the data, and you could unwind the stack and lose your instance of the variable. So consider using read-only, but I'm really leaning towards say, hey, forget it, just do not. I'd like to say that, but I want to get it. Do not use record classes and record structs as entity types in the framework. The reason being that entity framework depends on reference equality to determine instances, and so you don't want to go ahead and change the implementation of that. So it's a corner case, but in entity framework you don't want to go ahead and use record classes for those. There's an example right there. Notice that a positional record class and a positional read-only record struct declare init-only properties. So for those of you who aren't familiar, the idea is that you can have a property and it's declared as init, which means that it can be changed anytime until the instance is instantiated. That includes modifying it inside the constructor. You can go ahead and change the value to something else. But once it's instantiated, you can't modify it. The reason this is important is because if you're going to go ahead and use an initializer, so I declare, let me type some code here somewhere. Person equals new person. Anyone want to guess what I'm going to type here? Totally surprising, I know. You could do something like this. And now the instance when I instantiate person is going to be assigned Inigo Montoya. I guess it's not very interesting if I change it to the same thing. Yeah, that's true. That's a good point. Thank you. But I have validation on the proper. No. So in this case, I can actually change it after the fact. I'm going to go ahead and modify the name. So I declared an instantiate person has one name. I can change it to something else. All of this is possible with init. But what I can't do is this. That's not allowed because it becomes read-only after the instance you have. So this is just a reminder to make sure you're sort of up to date on what's going on. And by default, a record class is read-only, but a struct has to have the modifier of read-only. And you cannot put the modifier read-only on a record class. Just so we're all clear on this very obvious distinction between record classes and record structs. Let's see if there's anything else. Oh, it's important to note that mutability for records is shallow. So if you change something further down, like if I have a property that's a reference type and I change that, that's totally possible. I can't change the instance that I contain, but I can change the data within the instance that I contain. So just be aware that the read-only modifier only is very shallow in terms of what it controls. Okay, here's another one to sort of consider. When you're going to go ahead and use your range and index operators, so these were introduced in C#8. When you're going to go ahead and use your range, I think it's much clearer to go ahead and designate using the hat operator to identify, to do favorite target type new over var. Sorry, that's a different one. Do favorite. Where's my guy? Do use the index operator to access elements from the end when that's available. So whenever you can, you want to go ahead and index using the hat operator to do the reverse, go back over the type, rather than doing, oh well, this is going to be the length -1, right? That's the alternative. Let's just go ahead and use the hat operator. That's a clearer way to go ahead and design it. So these are just minor ones, be vectorial. So here's another interesting one, sort of something that maybe you're not aware of, if you're not aware of this coming in C#10. But there's the ability in C#10 for us to go ahead and declare a caller argument expression. What does this mean? What capabilities does this give you? I'm going to make the screen a little bit bigger here. More than that. So the statement was, is this where we get access to the name of what was passed in? We get access to the entire expression as a string, even if it's not a single variable. So what happens in this particular case? When I go ahead and call here, throw if null or empty or white space, and I call this method right here, I will just do it in line here for the fun. So here I'm going to go ahead and invoke it, and I'm going to go ahead and specify null plus null, which is ridiculous, but anyway, we'll do it anyway just for the fun of it. And then what it's actually going to do is it's going to go ahead and the C# compiler will inject the value, again, this is pseudocode, you can't actually do this, but it will inject the value null plus null plus null into the string argument that has the parameter is decorated with caller argument expression. So this is really useful for things like logging or exception handling. You can think of the case where you're writing a unit test and you do an assert, and right now you do assert true, and all you get back is, no, it's not true. It's really unhelpful. I'm like, oh, frick. Now, well, what wasn't true? And I have to go figure out what the exact expression when I called is true, or if you're in X units, it's going to be true. So right now today, I get an error coming out. The message says, this is not true. And I have no idea which line. I mean, I know which line it was on, but I have to actually go look at the expression. When you have a caller argument expression, it actually takes the entire text of the expression and injects it into this parameter here, which I've called, I don't have a name for it. Did I delete it? What did I do? Expression. What? It was argument expression, but I somehow deleted it. Anyway, so here, essentially what happens is argument expression gets injected by the compiler with the value null plus null plus null, which doesn't compile, but it's a nice idea. Make sense? So there's a couple guidelines around this that are very important. The most obvious one, and it's absolutely critical, you want to make sure that the value you pass in for this string on the constructor of the caller argument expression attribute, the value must actually exist. This parameter must exist. And it must have that same name. You would think it would be nice if you could do this, but that's not supported. You can't do that in the current instance of the language. I hope it gets added in the future, but it's not there today. So you need to make sure, obviously, that this value matches an existing parameter, that there is such a thing. And clearly we should write, if there's not one already, we should go ahead and write an analyzer for this. The second thing that's more interesting, and I want to be sort of bold in saying this, Microsoft has several of these caller argument expressions, and they're not following this rule. So I want to be very clear on why I think this is important. Firstly, you'll notice you should always go ahead and assign your caller argument expression the value of null. The reason you're doing that is to make sure that the user isn't required to actually specify the data. Which would completely defeat the point, right? That'd be ridiculous. So we want to make sure that this argument expression is optional, and so we want to go ahead and assign it a value. That's important. But the thing that Microsoft has not followed yet, and I would advocate you consider doing, is you should go ahead and declare this as a non-nullable string. A non-nullable string. And the reason for that is I don't want people to be tempted to go ahead and provide the value here. Oh, I don't know what I should do. I'll just put null. I'm sure the compiler will figure it out, because now I want you to get a warning when you do that. Rather than saying, well, because I'm assigning not null as the default, let me go ahead and make this nullable. Well, now the temptation is, I don't know what this means. I'm not familiar with caller argument expressions. Let me just pass null, which completely defeats the purpose of the whole attribute in the first place. So what was that? Oh, details. Thank you. So my point here is that even though we do have examples in the framework where that is declared as non-nullable, I think it is way better for us to declare it as nullable, tell the compiler we know what we're doing by using the null forgiveness operator with the bang right there, and assign a null. If you like, put a space. It doesn't really make any difference, but the memory consumption is better here. And by doing this, we ensure that nobody by mistake will go ahead and inject null, and therefore defeat the purpose of the compiler being able to inject a value. Questions? Yeah, that's a good question. There is no way to hide it from, I mean, you don't have any control over IntelliSense, so there is no way to hide that from the IntelliSense. And I mean, it's imaginable that you can come up with a reason to do this. And it is default, so you know, I think when you type these, you sort of get used to it. Most of us, when we see optional parameters and we don't think they're important, we just don't provide values. I want to remove the temptation for you putting in something that you don't, that would actually be bad. I don't want to defeat the function. But yeah, the compiler does show this today.
What would be the use case for allowing the user?
It's not, so the question is what would be the use cases for allowing the user? I don't think there's any reason why a user would ever specify this, but in order for them to make it available in the language without changing the language in some way, this is the way they sort of foist it in with current constructs and just using an attribute. So it's not that they actually wanted to allow you to do it, it's that they doing so allowed me to have sort of C# valid syntax for providing parameters that don't, magic injecting.
Provided, does that override?
Yes. Yes. So the question was, if you do provide it, will override, and the answer is yes. You don't want to provide this value.
Use case for providing it. You've got native expression, an alias.
Yeah. I mean, you know, in the case of, you know, so I guess the question was, would a use case for providing this be a way to provide an easier expression for the user to see? I personally have never encountered a scenario where I've decided that I would want to go ahead and provide my own value, and basically what I'm essentially doing is saying, yes, the actual expression I pass is one thing, but let's pretend it was another thing. I'm not sure I want my message to show up that way. That seems...
Yeah, if you want.
Yeah, that's a good way to do it. I think, so one case where you'd like to do this, if you want to write confusing code, that would be a good example. I think that would probably justify it. If you want to write confusing code so that when it behaves in a way that's unexpected, you could confuse the programmer who's debugging it. That would probably be a good example. So there is one, there's one. How are we doing? Good? Yes? We're doing good? There's a lot of like, oh my goodness. Okay. Okay. Of all the features that we're going to talk about tonight, this is the one I hate the most. So I just want to be upfront, and those of you who have heard me talk and no doubt heard me whine and complain about this particular feature. Oh, by the way, before we get into the feature, I want to point out that it was fixed in C#11. And then that fix was removed. So I'm really excited about this fact that the feature was fixed and then taken out. That's just great. So first of all, so we're talking about nullable reference types. This is a feature that was added in C#8, and there's a bunch of guidelines around this that I think are pretty important and pretty compelling. So first of all, consider, that means don't always do this, but consider, you should always consider turning on nullability for the largest possible scope. And generally that means inside your project file, or maybe even inside your props file that will then get injected into your property file, into your project file. You should go ahead and turn on nullability. What essentially this does is it sets you up so that nullability and your nullable intent is declared from the start. However, you should take extreme caution if you work in an existing project that has entity framework. Do not turn on nullability without understanding the implications. Because, for example, if you turn on nullability in your entire entity framework project, and then you regen your database, and you haven't gone explicitly and said, no, it's not a string, it's actually a nullable string, you will now change your database to take all those indexes that you want to make not be nullable and change them to be nullable. This is probably not what you want. It's extremely unlikely. So when I say turn on the largest possible scope, be very careful about doing this in any frameworks because the consequences can be fairly severe. I think I'd also like to point out that when we say turn on the largest possible scope, I look at a migration idea of going into nullability. If you're trying to migrate to sort of nullable reference types, my approach would be, hey, turn it on at the project level and then run a PowerShell script that injects one line at the top of every single file, which is turns it off. Well, that's kind of bizarre. Why am I doing that? Because you're setting yourself up so that as you open up a file, you can then delete the nullability disable, delete that line. Now the file is set up, and now go through the file with fine-tooth comb, and actually turn on nullability appropriately as the way you want it to be. Remember that by default in C#7, when you declared a string, it is a nullable and expected to be nullable string. In C#8, with nullability turned on, it is now not nullable. Your intention, it is now not nullable. Do not do this without being intentional about what you want to do and what you want it to be nullable or not nullable. So if you're in a migrating scenario, so if you're in the case of it's a new project, dang it, turn it on is the very first thing. You generate the file, .NET new class lib, .NET new, console. The first thing you do is go to your CS project file and turn on nullability. If it's not already turned on, which by the way is starting to get it turned on, depending on which version of the template you're getting. So we're getting this feature there, but it wasn't there in 809. So it depends on which version of the project template you're using. So just turn it on right away. New project, just have it turned on and start living in a world where you have nullability. So once you've gone ahead and enabled it, do address nullable warnings when nullability is enabled. If you've got nullability enabled, don't ignore those warnings. As I say, what I would do is actually turn it off at the top of your file if you're not ready to address it, because you're basically saying, I don't want to pretend I've got nullability and not address the warnings. You don't want to start in a world where I've got thousands of warnings. So turn them off when you're not deal with them. But once you've gone and said, yes, nullability is important, you should examine and deal with all nullability warnings. Don't ignore them, because there's an expectation by your fellow programmer that when they went ahead and declared something as string, meaning not nullable, that you are paying attention to that warning, and they don't need to always check for nullability. I say that with a bunch of tentativeness that I'll explain shortly, but the rule right now is if you have nullability turned on, deal with all the warnings appropriately. Okay. If you have a public API, a public class library, or whatever, it doesn't matter. If a public API, somebody is calling your APIs, even if you have nullability turned on, you do, meaning you must always check for nullability. Why do I have to check for nullability even if I have nullability turned on and I specify that the parameter is not nullable in my intent? Why do I still have to check for nullability? So the suggestion with serialization, it's not going to make a difference in your serialization scenario. Interesting scenario. Why do I need to check for nullability even if I declare my parameter as not null? Austin. Yeah, when you go ahead and declare something as not nullable, meaning you don't use the question mark, when you go ahead and do that, it makes absolutely zero difference to what is compiled to IL besides metadata. The only thing that is added to your code is metadata that allows the consumer of your API to know what your intent was. There is no null check. Therefore, if you are being invoked because you have a public API and somebody is calling you, they could ignore the warning because they didn't follow the previous guideline. They just decided, I know better. Warnings are for, I'm going to use something derogatory, so we'll take it away. Warnings are not important. I'm going to just go ahead and leave the warning there, and they could invoke you, and guess what? If you don't check for null, you're going to be dealing with null, and you're going to be throwing a null reference exception, most likely. So you want to make sure you go ahead and check. Or another example, what happens if your API is called from C#7, C#8? They don't have the ability to have a compiler that tells them what's going on. There's none of that going on. So they're going to go ahead and invoke you, and you didn't check for null. So you want to make sure that if you're going to go ahead and have a public API for non-nullable parameters, that you always check for null. Do specify positional parameters as nullable. If you're going to go ahead and provide a positional parameter, and you're not going to implement the property, you will note that that parameter has no validation on it. So again, assuming you're in a public API and you go ahead and define a record, and the record has a positional parameter that is a reference type, and you declare it as non-nullable, there's nothing that prevents anyone from passing in null. Okay? So unless you're going to go ahead and override the property implementation, you should ensure that all reference types positional parameters are nullable. Now, I said that unless, if you're going to go ahead and provide a constructor, there's a whole bunch of reasons here. You essentially want to provide a property that checks it, then you don't need to worry about this. Okay. Do declare backend fields as nullable for non-nullable properties if there's no reason for default. I think the best way to look at this is in a by example. So I have here a person record, okay? And you'll notice that has a name property. A couple things to note. First of all, the name property is declared as non-nullable. Okay? You should not be assigning null to this property. Comment number one. Comment number two. I don't trust that when you invoke me, you will not pass null. I don't trust that you paid attention to the warnings. I don't trust that you're calling from a version of the language that supports nullable. I don't trust. And I'll have an example of this a little bit later, but I specifically am using an argument null exception dot throw if null to throw an exception if the value is null. So we've had tons of ways for checking for null. There's tons of ways you can go say, well, if it's null, I can do question mark operator. I can do a whole bunch of stuff. Going forward, starting in C#10, I think it's C#10, you want to go ahead and do an argument null exception dot throw if null. How is this working? Any guesses? There's something magical inside this throw if null. I can pull it up here. It is! Credit, ding, 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 ding. It is using a caller argument expression. So this method, which is new, this method has a caller argument expression. When I pass value, it will then go ahead and inject the text of the first parameter so that I know what it is that was null when this is thrown. And the value actually gets thrown into the exception because this is going to throw argument null exception. So second thing, we want to make sure we're going to go ahead and validate the property, and we're going to go ahead and use the argument null exception dot throw if null to go ahead and inject it. And then we have this weird characteristic here. Why is the field that backs the property, why is it nullable? Why is the intent nullable? Tyler. The statement was, I deemed the default name of Inigo Montoya not fit for the situation. But in this case, I'm saying the name could be null. I'm not saying the name could be not null. I'm saying the field that backs the property could be null. Why am I doing the exact opposite of what the property that's wrapped in the field has? I'm saying here, string is not null, but the field itself is null. Why? So it is true that when I new up an instance of person, it is uninitialized. That's a true statement, and maybe what I should do is actually have a constructor. The example is a little bit short here. But it's true, name is not initialized when I go ahead and instantiate this version. That's a true statement. I actually think that, can I edit this? Hey, look at that, I can. We should really, we should have a constructor here. Yeah. I didn't say you had to use positional parameters, but you should have, no matter what, I should have a constructor. So I can do it this way, or I can declare it as a constructor. 1 second on the question. Public person string name So these are essentially equivalent. I'm going to do it like this way, just so it's very explicit. In this case, I'm being forced to initialize it because I only have one constructor. The constructor goes and takes a name. I'm initializing person here. Why are we saying that name needs to be declared as nullable? Nullable, not null. So this is not a value type. This is a reference type. And you cannot instantiate person without providing a name. You could still pass in null, but you can't set underscore name. Private. I think Austin's got a clue here. I'm not sure if this. Bummer. I'm inside a notebook and I got it. So the reality of it is, if this is not declared as nullable, there will be a warning on the constructor for person saying I've not initialized a non-nullable type. So the compiler issues a warning that says underscore name is not initialized. Please make sure you initialize it. And now I have a warning. I am consistent. My property wraps the field. The data types are consistent. Everything's hunky-dory, except the compiler has said, wait, your intent is that underscore name is not going to be null. You're not initializing it. And now it has the potential of actually not being null. Now, there is a problem here. If the compiler was clever enough, it would know that I'm initializing name and calling the property, and name instead here is verifying that it's not null, and then assigning the value. Like if it actually was able to go through, a fairly complex, analysis, then I wouldn't have this problem. But the compiler is saying, you declared a field, it's not nullable, and it's not initialized. We got a problem. Please check your intent. Remember, it's only checking our intent. And so to get rid of the warning, we know better than the compiler, and we're going to go ahead and declare it as nullable, knowing that it will never actually have the value null. Because our ability is way more complex than the compiler is essentially what it's saying. I seriously think the hassle of declaring any non-nullable reference type property is a pain in the patootie. But the reality it is, if you have a public API with a property that is not nullable, this is the way you got to do it. You have to validate that null is not being passed. You have to deal with all the warnings, and the only way to get those two things to work is to declare your property like this. Questions? Okay. Prasad, he says, is there a guideline for using collection types IEnumerable? And I have no idea what the context is. Can you give me a little bit more context to that? Kevin, have you seen chat? When we were discussing the name property, I don't have any additional guidelines because of C# 9 through 11 features that affect IEnumerable. So yes, there are, so let me just be clear on the statement here. Yes, there are significant guidelines around IEnumerable. However, there are no new guidelines around IEnumerable that have been introduced because of language features in C# 9, 10, or 11. Probably the most significant of the IEnumerable guidelines that I will mention is that you generally want to declare your properties that are things that are IEnumerable as read-only, meaning you cannot go ahead and replace the instance of the collection because that will force somebody to check for null before they iterate over your collection that's a property. So if you have a property on something here like If you have something like this, then the guidelines here around the C# guideline is this should be read-only. You should not be able to go ahead and modify it because of the fact that once the collection instance is there, I should be able to iterate over it without first checking for null before I do. So that's sort of one, but that's not a new guideline. That's existed for a long time. Okay. We have finished everything related to nullable. I've got a few more here. A couple more on guidelines. I think these are actually duplicates. Got that one, got that. Okay, we're good with that one. Just a couple quick ones on parameter pattern matching. I think pattern matching is awesome, but it turns out that the number of use cases for when you need pattern matching is way less than we actually expect it to be. And the one guideline I want to give around pattern matching is if you have the opportunity to use polymorphism, meaning I have a type, there is inheritance involved, I can do a dot operation that says move, and the pet moves differently than the car, which moves differently than the plane, that example. You don't want to go use pattern matching on how to resolve something can be resolved with polymorphism. So my only guideline around the fantastic feature of pattern matching, which has a whole bunch of new syntax and is really powerful to do a lot of really cool stuff, is don't use it if you can use polymorphism. So it's just a simple guideline because we tend to sort of see this hammer called pattern matching. We sort of watch the other languages and go, oh, this is the best thing. We should use this always. And just remember that if you can use polymorphism, you shouldn't be using pattern matching. What number are I on? 8. Null checking. So I've done an introduction to this already. First of all, if you're going to check for null on a parameter, when checking for null parameter, use argument null exception dot throw if null. I mentioned that earlier, but I want to cover explicitly when we talk about null checking. You want to make sure that you go ahead and use that for checking for null. And there's a bunch of other ways that were available before this method, and they were kind of obtuse and that's not the right word. They were verbose is a better word. And so going forward, this is the way you want to go ahead and do it. If you're going to go ahead and declare a local function or anonymous functions, go ahead and use the keyword static. So you'll notice here I'm declaring static inside this declaration. What does static mean in this context? This is a C#9 feature. Why would you go ahead and use static when declaring a local function or anonymous function? So it turns out that static in the constants of declaring a local function or anonymous function does not mean static. That would be a misunderstanding. I don't know why you would think that. Yeah. So the reason, of course, that this is confusing is because C# is limited by how many new keywords they can create without causing your code to compile. Anyone know what that number is? How many it could be? The exact number is 0. If they add any new keywords to the language, they will probably break your compiler, your existing compiler out there. So it turns out the C# is very limited by how many new keywords they can add. They can add contextual keywords. So just to be clear, a contextual keyword means it's only a keyword in a specific spot. That's totally viable. For example, in, I don't know, C# 5, they added things like async. That totally makes sense because it only matters in a specific place where you could never have put it yourself. So because of the fact that new keywords can't be added, static means something different in this context. Anyone else know what this static designation is for you? Reese? Yeah, it has to do with closure, which is a similar word to capture. They both begin with C, so we're close enough. It turns out that if you declare it as static, you cannot use any other variable within the scope of this method. You can't inside this expression. And that's really important because when you have closure inside there, you could be modifying variables in a way that is not what you expect. And so generally we say just use static so that when it doesn't compile, you could remove the word static, but it made you check, did I really mean to have a closure over a variable that was declared within the scope? And so the guideline here is just by default, declare your expressions, your local functions as static. And by doing that, you will then explicitly present, oh yes, I really did mean to do a closure on a variable that was declared outside the scope. Static was added in C#9. Plus or minus 3 or 4. I'm pretty sure it was C#9. You know, it's really interesting. I used to sort of walk an audience through when I went through different languages. It was like which version was added when, and not only is it not significant, it was more just just how smart you were. Actually, the purpose of that was to see how smart I was. But it turns out I'm not smart enough. Once we got to 10, I can't actually remember, so I've lost that capability. I also turned 39, so that made a difference as well. This one's not that important. We're gonna keep. Okay, don't know why that's not coming out, but we'll keep going anyway. So, not that this is controversial or not. This is we're going to start with the question of, when is it okay to use var? Go for it. Good luck.
Like, if the type on the right-hand side of the assignment.
Yeah, so that's absolutely true. If you can easily identify the data type of what the implicit variable declaration is, meaning var, then by all means you should use var promiscuously. That makes a lot of sense. However, if you're going to go ahead and declare it, and you're going to go ahead and retrieve the value. So for example, I'm going to go ahead and retrieve the value from some other data type, like person.age. Is that a string? Is it an int? Is it a double? It's completely unclear when I do .age. What is it? Am I getting back months? Am I getting back, like, what is the data type? That would be a case where you should be reluctant. I would say avoid using implicit declarations when you don't know when it isn't implicitly obvious what the data type is. Now, it turns out this is very controversial because for those of you who program in those archaic languages like JavaScript, for example, you don't really have any choice and you use var all the time. So you're so used to not having data types, knowledge about your data types, that you think it's not important. But for those of us in more modern languages, we prefer to actually know what our data types are. And so this is definitely controversial, but I would argue that if you're going to use var, you should always know what the data type is. And I would argue further, you don't need to worry about this in a constructor anymore. There is no reason why you would ever use var when invoking a constructor, because when you invoke a constructor now, you can use a targeted type new, which means you declare the type on the left and you just use new on the right, and you don't actually have to specify the data type on the right. I can't see any reason why you wouldn't always do this. So my guideline here is do, meaning always, use targeted new type expressions when invoking a constructor of the type. If for those of you who like to type more, if you want to go ahead and declare the person and then do new and specify person on the right side, by all means. But don't go ahead and use the second example, which is an implicitly typed person here, where I have person on the right. You're typing more, it's not as clear. Just get out of the habit of using var, because you don't know what the data type is. Yes. This is true. The interesting thing, I will give you an example that's sort of where I became opinionated about this. This is when var first came out, so this is C#3, plus or minus, no, I'm just kidding. It's C#3. So when var came out in C#3, which is when Link was added to language, I remember going to Microsoft and I was invited to sort of view this new version of Link. And the C#, the person working on the C# compiler team went ahead and declared his variable with this new feature called var. And he got 3 lines down and he couldn't get his code to compile because he actually had no idea what was being returned from the link expression, and he thought it was a collection and it wasn't. It was actually a specific type. And it took him a significant amount of time in front of the audience of supposed experts, me excluded, of course. The supposed experts knew what they were doing, and you couldn't do this. And at that point I go, okay, you should only use var if you have to. And there's only one case that you should have to, and that's if you have anonymous types. And we don't use anonymous types anyway anymore because we should use tuples. So there's pretty much no case where you should use vars. Do you have a question? Questions?
Those cases in person.
So the question was, in either of these cases, can person be assigned to another data type? And the answer is no. Right? You cannot change the data type. It's a strongly typed language. It is not nearly as sophisticated. No, that's not the right word. It is not nearly as broken as JavaScript. It is actually data type. So at a compiler at the IL level, these two lines are identical. There is no difference in the IL between these two lines. They're identical. Yeah. So this is actually this is a totally valid point that Alston brings up here. I don't know if I can do this. I manage compiler here. So in here, this is a fairly common scenario. So I can go ahead and do, var data equals text dot select item goes to item. There's that scenario, like, well, what the heck is going on here? I will type, like, literally, I will go ahead and type it just like that, and then I'll do code control period enter, and it'll go ahead and change it to the data type that I want. There is it's actually like that, but anyway. So I will use that all the time to go ahead and deal with converting the type, because I haven't actually figured out exactly what it is, but I want to use explicit declaration. And I'll go ahead and use the IDE to fill it in for me. And I think that's a very common scenario that is totally. By the way, this is the first one that I think there's a fair amount of controversy on. But if you go to the case that I'm doing right here, with the introduction of targeted type new expressions, there's no reason why you wouldn't always do this. So while I understand, and I'm obviously familiar with religious battles being fought over whether you should use var or not, I don't see any reason to continue the battle when it comes to using a constructor. You should always use targeted type. This is another interesting one that we're going to get into here. So we have, this one's not showing up in code, so let's just go into here. Go ahead, I'm listening.
Let's say, person answer. What happens?
Sorry, give me that example again.
Person. Not variable.
So the answer is you can change the type on the right as long as there is inheritance or a cast, an implicit cast operator. You could assign something different to it, but the variable itself's data type cannot change. It is still that data type of the variable. So the left hand, when you say this is a person, you could assign it a child. Sorry, that's a bad example. You could assign it an employee. That would be a valid assignment because an employee is a person. Well, in most cases, I've got some exceptions within IntelliTech, but we'll just ignore those for the moment. You would go ahead and make that assignment, but the data type is now a person. When you do a dot operator, you will not get an employee ID. You will only get name.
That's true of the var.
It's true of the var declaration as well. Yeah, so standard polymorphism rules here. You would go ahead and use that. I should do a clarification here. So if you assign an employee to a var, the data type will be an employee, and if you then try assign person, it will fail. The compiler will object. Same with an interface. If you assign something, it is the interface. The data type will be declared as an interface. And if you then try assign a person, it will fail because person is not always the same interface. That's not true. It would actually work because the person is always the same interface. The fact that you're asking the question proves my point, by the way, just so we're clear. That's why I sort of feel like this is important, is the fact that you're sort of wondering what is the behavior when I'm assigning the type really sort of emphasizes, do you really know what that variable is? And shouldn't you? Like, that seems fair. Anyway. Not that I think this is important or anything. Okay, so Details.
Oh, I noticed are
Yeah, you can't. Yeah, that's absolutely true. You cannot declare a var as null because what is the data? You cannot assign null to a var because what is the data type of that to it?
Well, yeah,
But that would be
you do it if you
right. But then the data type is it's the data type is null. So again, these are sort of weird scenarios. Why would you ever do var thing equals null? Like what? Or like because obviously what you meant was thing. See, that's so much clearer. It's obvious. Okay. Okay, so I know that I've got people in the room that have strong opinions about this, and so I'm going to sort of tread tentatively here, but let me sort of give you my take in here. Right now, in the latest version of the C# project templates, when you go ahead and create a new project, it adds a global using file, globalusings.cs, where you can go ahead and put your global using statements. Just as a reminder, a global using statements mean now that using statement is true throughout your entire project. Like that's totally available to you through the entire project. So you put this statement into a file, and it's now available through the entire project. That is really cool. This is up to the level of importance of file-based namespaces. Like use these always. If you've got a standard declaration, if you've got a test project and using XUnit or Microsoft.Visual Studio.TestTools, whatever, like how many times do you really want to type that in your test project? Why do you have to put it at the top of every single file? I did it once, can't you know that? I mean, come on. Well, we finally realized that this is important, and we're going to go ahead and allow you to have global using statements. And so you would tend not to put these inside every single file, and you wouldn't put them willy-nilly because you've declared it somewhere. Which file did I put this in? I can't really recall. Let me go cycle through them. Oh, let me open a PowerShell script to search through where I had all these. Yeah, ridiculous. Anyway, so I want to certainly say that we should use these liberally. If you really are requiring a user statement throughout the majority of the files in your project, you should go ahead and have implement global using statements. And I would argue that you should put them inside a file called globalusings.cs. Maybe you want to call it usings.cs, but there's a fairly well-established sort of principle at this point that you're going to put in a file called globalusings.cs. Do that. However, there's another way to do it. You can also go ahead and in an item group of your project, you can go ahead and do an include of the exact same thing, which allows you to have the same functionality, but it's now inside your project file. Is everyone aware of the feature? You understand what we're doing in doing this? Okay, so I've already said if you're going to have a global using statement, you should go ahead and put in a file called globalusings.cs. The question is, which of these two is better? Okay? And I did not make a stand. And the reason I didn't make a stand is because Visual Studio is creating this global usings.cs, I'm kind of reluctant to go against what the tooling is doing. However, I will express a personal preference that says I think we should move towards putting these inside CS project files. And I know that when I write my code, I always choose to put them inside, like there's no exceptions. When this feature came out and I understood it and I thought it works, I always went and put inside the project file. But there's a couple caveats. First of all, not everybody knows about all the qualities that you can put inside a global using statement. I mean, inside a project file. Second of all, the tendency is for you to go ahead and modify your property group and try to put this using include inside your property group, not inside your item group, because that's where you're used to working with things like nullability. That's where things like implicit usings is placed. Let me see if I got this inside a project here. What's wrong? So when you're going ahead and modifying your property group, you're going to go ahead and put things like implicit usings, so you get system for you throughout your entire project. You're going to put your target framework, and of course you're going to go ahead and go, oh, well, great, let me just go ahead and put my include here. You know, include, no, sorry, using. And you would be wrong, because it doesn't work. Of course, the compiler doesn't tell you it doesn't work, because it's XML, and There's no schema, but that doesn't have no effect, because what you actually need to do is put it inside the item group down here. And so we're sort of, I think if you were aware, you should just always put them inside your CS project file. There's another really important reason that I think is extremely valuable. You can put conditionals inside your MS build file, this project file here. And because we can put conditionals, we can actually go ahead and refactor any data that we have inside the project file into a props file. So we can actually refactor, or actually a targets file. We can refactor this into a target file that's standard for the entire solution, not just the project. So now let's imagine we want to put a using statement for our testing namespace. Well, I don't want that using statement to be for a testing namespace in a production project, but it's not a test project. Well, now I can put a conditional that says, if this is a test project, then have this global using statement. And if it's not, you don't do anything. So I just think the capabilities are better. And I like the fact it's just cleaner, just always put it in here. But the syntax is definitely more complex. And I don't want to ignore that fact. If you're working in a team, this is new, they haven't been using C#9, that's C#10 actually. That seems like we're dealing with complexity I'm not sure is warranted. So I'm not willing yet to say, hey, you should always put it inside the CS project. But I do know people, the initials are Kevin Boss, who are fairly opinionated about this. But, and I happen to agree for my code. I'm just not yet willing to say, all the code. Now, it turns out that as we write the C#11 book, and I say we because Kevin is helping me with this, we're going to have a fairly heated debate about this topic. And I'm not sure, we haven't actually figured out what the hierarchy is. So I don't know how that's going to play out. But we'll know, in short order. Okay. Globals. Oh, yeah. So with C#, I think it was C#10 this came out. Yeah, C#10. In C#10, we have the ability to go ahead and use dot notation in Reddit instead of the colon syntax when we're going ahead and doing property pattern matching. And I would say just always do this. I can't come up with any reason why you would favor this syntax other than the obvious it's not available in the version of the language you're using, which we've already said we don't count, we don't talk about that. So in all cases, use property pattern extended dot notation for your pattern matching when you're doing pattern matching. Here's a fun one. If you're programming in ASP.NET, starting in C#9, and you generate a new ASP.NET project, it does this really nice thing of putting your beginning, the startup syntax into a file that has no class. Literally, there's no class, but I mean the class and not in C# context. So it has no class, it has no method, it's a top-level statement. And I want to say, don't do that. Okay, so let's be very clear. Top-level statements are a fantastic addition to the language. Because if you happen to be writing a book, okay, and you want to write hello world, it is insanely complex to have to go and say, well, declare a class, but just ignore that. I'm not going to explain anything to you. And then go ahead and declare a method called main, but ignore that because it really doesn't matter. We're just teaching you hello world. Oh, yes, and then you can do console.writeline. And then don't forget you have to do a using statement. Oh, wait, no. I mean, like, that's absolutely insane. So top-level statements are fantastic additions to the language. This is why C# can compete with languages like Python. Right? This is a good thing, okay? But in real programming, real programmers don't use top-level statements, okay? So that, are we okay? Are we comfortable with that? So you're welcome to go ahead and use a top-level statement, but when you do, we're going to pretty much assume you are not a real programmer. You haven't sort of got to that level yet. So Seth points out that this is now an option in Visual Studio, but the default is wrong.
Yeah.
I just want to point that out. I've already talked about this. And that's it. Questions? No questions. we'll start with two from the speaker's point of view. So my first question, was this helpful? Was this interesting? Was, you got some value out of it? The more important question, of course, is, was it entertaining? That's, yeah, okay. We got an entertaining. I assume you're voting for the audience there, Kevin, the online audience. We got some thumbs up there. Okay. Okay. I haven't yet posted this into GitHub, but this is where it's going to be. There is a preliminary project up there. You'll notice that some of these files are markdown files. Some of these files are interactive notebooks. I haven't converted them all to be the same. So I will get that updated and get them all to be interactive notebooks so you can actually go ahead and run this code and stuff. But the guidelines are all there. I've gone ahead and presented it. And we'll continue to sort of refine this as new versions of the language come out. But unfortunately, C#11 doesn't have any new guidelines that I think are worth mentioning or introducing you to, except the one that they removed. Like, that would have been a great guideline, but they removed the feature, so we're stuck with my help. Okay, have a great night. Thanks, everyone. Have a great summer, since we won't be here. What's that? Oh, thank you. That's so helpful.
Very top.
See, I didn't pay attention to the warnings. In theory, you're supposed to have a dash. What's that? Say again? I need to put this on a class? Oh, yeah, got it. Yes, I get it. Yeah, I get it. That was the problem. Okay. Okay, sample of a top level statement. This is really complex.
Here we go. Ready?
Oh, you ready? Okay. In case you guys had any doubts. There you go. No. You can do this. You can do this anywhere, anytime. It can even be in class lib. You can go ahead. Actually, you can't do it in class lib. Yeah, that's true. You can only have one of these. I don't think you can do this in a class lib. So you can't do it in any project. It has to be an XE. Yes, you can add stuff to. You can add stuff to the name, but the name is like nasty, right? It's. Yeah, if you're going to go write a partial class to go ahead and add additional functionality to the one that's going to have in the top level statements, trying to come up with a nice way to say this. What was that? That's right. Is there anyone's, so for those of you, there's not a lot of people programming in C# 9 or 10 here, but I'm curious, are there any I'm missing that you really wanted to have? Oh my goodness, why didn't you have this guideline? Yeah. A question coming in, excellent. There really is a long delay. Am I still online? I was assuming that I was no longer online. Oh my goodness. It's a good thing I didn't say anything bad about our online audience. The suspense is killing me. When await keyword was introduced, you could not write it inside a finally block. But in later versions it was possible. But MS never explained how they made it possible. Okay, so this is a true statement. We'll start off with that. You can now use an await keyword, and I think it came about in C#9. But they never explained how they made it possible. But why? So are you asking me what is the C# compiler generating in order to be able to put await statements inside the compiler? Is await inside finally a good practice? I don't have any cases where I would, if you need to put an await statement in a finally, I think you can do it always. That would be my answer. So this was a frustrating restriction on the capability of the language when you couldn't put this inside a finally statement. The fact that you can do this now, if you need to have an await and it makes sense to put in a finally statement, you should absolutely go ahead and do that. There's no reason why I wouldn't avoid it. Yes. Yeah, it was a very complex compile, and they just didn't implement it. So this was something explicitly that the C# team just didn't get done by the time that feature went live, and that's why it appeared in later versions, because they figured out exactly how to compile it. It's a fairly, if you think about this, you've got to unwind the stack, and you've got to manage the asynchronicity. It's a fairly complex compile. They just didn't have the feature completed, but it's now possible. I don't think there's a guideline here. I mean, if you need to put in a wait statement and a finally statement, do. If you don't need one, don't. Like, it's not really a guideline, or you should always do this, because you only do it if you need to, and now you can. You just couldn't before. It's not like I can create a guideline around that particular one. Okay, I don't think I'm that entertaining, and you guys are all still sitting down, so I'm trying to think what I need to do. You're excused. Should we pledge allegiance to the flag or something here? I'm not sure exactly what the deal is. Yeah, class dismissed. Okay, good. I do appreciate you guys coming. Thanks. It's good to hang out. I hope this was helpful.